Thank you, Agustina, for the kind words of introduction. Good morning, everyone. I hope you're having a great day today. And today I would like to take you on a hitchhike through the galaxy of API authentication and authorization. So stick out your thumb, keep your towel handy at all times. Let's go. First, a bit about who I am. My name is Dirk Nederveen. I am a Pygrunner since 2014. And the years also corresponds to the number of gray hairs in my beard. So that gives good hope for the next couple of years. I'm a husband and a father of 3. You can follow me on the Fediverse if you like. I'm a lead developer at Sphere. I really like working there because I get the opportunity to lead a team into excellence. And if you would like to know more about Sphere, maybe work with us. Talk to anyone wearing a sweater like this. And my current shiny is event-driven distributed systems, which I am happy to say. I don't do that for a living, so I can hobby around as much as I like. So before we dive in, we first need to ask us the big question, the ultimate question of life, the universe and everything. And you may know this. You want to change your password in some system, but before you do that, you get to ask the question. Please log in again. Why do I need to log in again when I change my password? That's one of the questions we'll be answering today. So hold on. Well, let's first have a bit of a look at the itinerary. You'll never know how you get at your destination when you're hitchhiking. But my best guess is this. We'll have a look at the stars. A bit of a map about what's authentication, what's authorization, how do they hang together. We learn why it's so important that we don't forget our towel. Talking about permissions, entitlements, and scope. We'll visit the restaurant at the end of the universe and see how authorization is done at the edge of a system. And at the end, we'll find the total perspective vortex and see how it all hangs together. So first, let's look at the stars for a bit. We're talking about authentication, often called auth-an for short. And that's about the question, who are you? Can you enter? And the next big topic is authorization, usually called auth-z. And that's about the question, what may you do and what can you do? So this is a screen or something similar. It's probably familiar to most of us, a login screen, asking for an email address, a password. And this is about the questions. The email address is, who do you say you are? The password is, give me a reason to believe you. And many systems actually have 2 paths. When you enter an email address and there's a single sign-on provider configured for that domain, then you get sent to your single sign-on provider, and that flow looks a bit like this. You enter your username. Sometimes you get sent to a single sign-on provider. For example, if you authenticate to some Microsoft stuff, often you get sent to the username password flow, possibly with a multi-factor authentication, and finally you'll find that you'll get granted access. This is a very, very big process, but it maps to 3 discrete steps: identification, a password, a multi-factor, and then you get access with a refresh token in some browser app. We'll look at all these steps one by one, so don't be daunted by this long diagram. First, identification. Wow, this screen is big. For identification, it's usually pretty simple. You type in your email address or your identifier, and the authorization server at the other end will check, do I recognize this user, this identifier? And if so, I should send them to some password flow because, well, you want to enter your password. The authorization server needs to know when you return, what person are we identifying. So let's, for that reason, we can set a cookie, and because it's pretty convenient, JWTs can validate themselves by their signature. So asking that, providing a JWT in the cookie is usually pretty handy. Next up, the password of the identification step. Well, we see a little password form, and we type in the obviously correct password. And afterwards, the authorization server will again check, does that match the user? Of course, we entered the correct password. Again, set a cookie, and now we redirect to the next step in the authorization flow, the multi-factor authentication. I have a little security key for this, so whenever I get into this step in some login, the browser asks me, please touch your security key. The user is presented some browser interface, does the necessary steps, maybe a security key, maybe a code from your smartphone. That response is sent to the server, and finally we can redirect to the app while providing a refresh token, again in some way that our app, that the authorization server can again know, are you actually identified as the correct user. So we saw a couple of things, a couple of authentication factors. The first one is what you know. The password is the most common one here. The second one is something you have, an authenticator app, maybe a security key or a passkey in the secure enclave of your computer. Another important factor is often what you are. Something biometric, a fingerprint, an iris scan. This is notoriously difficult to check over the internet because it requires some specialized device on the user's end. Other things that may be of interest is about where you are. If I usually log in from the Netherlands and suddenly there's an identification session coming from Russia or China, there may be something up. I might want to block users that are not from their original location. Maybe ask them for more verification steps. And another thing is how you behave. While you're using an application, are the patterns that you're the patterns of behavior consistent with what you usually do? This is usually quite difficult to assess. It means measuring a lot of clicking behavior, visiting behavior in your application. It's difficult, but if you have higher standards for security, it may be useful to look into. We won't be looking at these today, and let's continue. So we're authenticated. We could do that. Now what? Can I change my password already? No, because we're not authorized to do that yet. When I log in, for example, to GitHub, I want to change my password. Always, without fault, I get asked to authenticate again. That brings us to permissions, entitlements, and scope. Let's dive in deeper into the authentication and authorization in that part. So we're talking about permissions. And first we need to address the elephant in the room. That's the word, permissions. What does that mean? Who thinks permissions are something you store in your database? I see some hands maybe. Who thinks permissions are some claim on an authentication token? That's a bit of a trick question, because in most apps there tend to be two kinds of permissions. both user permissions stored in the database and token permissions as a claim on the session. And these are quite confusing because I have the same word for two different concepts. So let's try to find other words. And I have to thank my former colleague Joshua for giving me these words. The first one for user permissions, what I have learned to like is entitlements. What are you entitled to do? What may you do in theory if you're authenticated in the correct way? For token permissions, I propose to go with what we know from the OAuth2 spec. What's the scope of your token? How are you identified and authorized right now? And in a database, in some data model, that may look a bit like this. Entitlement pointing to one principal and one object with an access level. Of course, you can extend this. There may be lifetimes on entitlements. After this specific date, this user shouldn't have access to that object anymore because maybe that a license expires at that date, and after that, the user shouldn't have access anymore. And the scope, I couldn't get to a better definition than it's a materialized combination of an object and access level, typically on an access token. So let's dive deeper into that. Scopes is something you probably know from making, generating tokens for an application. Again, in our GitHub example, if you want to make an access token for GitHub, you get presented this enormous list of different scopes. And I think with the newest version of GitHub scopes, you can even give object level permissions there. I see some nodding. Thank you for validating my hunch. And this is a scope on a refresh token, because it's a token you can use more than once to get access in another authorization step. So again, let's call these token entitlements, just to keep the verbiage clear. And there's also the scope on the access tokens generated by that refresh token. Let's call these token scopes. And these things hold. A token entitlement is always a subset of a user entitlement, because if I'm logged in as Dirk, I have access to the Sphere repositories. Once my access for the Sphere repositories is limited, all tokens that I generated before will not get invalidated, but they can't get that entitlement anymore. And again, access token scope is a subset of the refresh token entitlements with which that access token is generated from. Now let's look at entitlements in interactive sessions. Often it's the case that entitlements are the same as the scope for the session. This is not necessary. And by using the OAuth2 scope request parameter for token requests, we can get dynamic entitlements and more granular access control, like in the case of changing your password. And in this way, we can apply the principle of least privilege. We're going again into a sequence diagram. And this is a bit how that getting a token works. I should have updated this example. Let's see, we're a user and we're in an app, the Sphere app in this case. In the Sphere app, I'm a super user, but that doesn't mean that I should be able to access all models or change all models immediately. I would like to have an extra verification step with that. So my app can check, does my token, my current access token, have the admin scope for model 42? And the example wouldn't be very interesting if I had at this moment. So my app can say, oh, please, authentication server, can I have an access token with that scope on it, please? Okay, says the authorization server. You can have one, but you need to touch your security key again. Because did you leave your computer unlocked in the office? That happens sometimes. But then, oh yeah, I see colleagues already trying to type, I will bring cake next week. That happens sometimes. But I take my key to the toilet because it's outside of the room. So they can't actually authenticate as me. Once I do the security key dance, in the background, my app can communicate with my authorization server. And finally, the model settings are being displayed. So you see how dynamic scopes, in this case, work great with multi-factor authentication. And you can add more layers and for your own applications that you develop. Think about what are very sensitive operations. How could I tighten the security of that? So as a bit of a recap, entitlements and scope. There are entitlements consisting of a principal, an object, an access level somewhere in my database, and a scope, a materialized subset of the entitlements. And scopes are always a subset of the entitlements. Ready. So let's continue. We're on the edge of the restaurant at the end of the universe. A little case study of how we do authorization at the edge of our application. In the Sphere app, we make maps. And the colored in bits are things that we predict. And I took great efforts to make a screenshot of things where some of the tiles were not yet filled in. That took a bit of effort with the timing because it's usually pretty quick. Our tile server runs in AWS Lambda, which is, for our use case, pretty great because sometimes when a map is being loaded, there are a couple of hundred requests within a second. And then for a couple of minutes, there's nothing in that being requested. So having a system that can handle that spiky load is good for us. And the backing resources, where the actual data for those maps is stored, is passed in as a query parameter, basically an S3 URL. And they look something like this. Project ID, a model ID, some unique identification, etc. And with these information, these bits of information, we can check at the edge at AWS CloudFront, does the token that you give to us actually give access to the project or the model? And that looks, we have this enormous computer, worldwide CDN with thousands, maybe millions of servers, and we ask it to validate a token. And the code running in AWS CloudFront looks a bit like this. It had to be JavaScript, which my colleague Mace is really excited about. And the most important parts are these. First, there's this part. We find the scopes from the token payload. And if any of the scopes has model access, if none of the scopes have model access, then we return a status code for a 1 being denied. And model access works pretty simple. We see, is there some model with read or read and write access for the specific model? Then we allow access. It's fairly simple. And because the data being secured here is not that sensitive, That's for our use case, it's okay. Sometimes you need more, sometimes you need less. This is a simple request response thing, and it works great for our purposes. So, looking at where we are, why do we log in again when changing a password? That's because being authenticated is not the same as being authorized. It's because our access token in our app had insufficient scope to do the action that we desired. And when we repeat our password or repeat a security key or web authentication request, we get granted a new access token, but now with the scope of allowed to change a password for a specific user. And with that, I would like to thank you all so long, and thanks for all the fish. And I see I have just a bit more time. So let's go to the bonus slides about token revocation in distributed systems. Sometimes you have systems not in communication with the authorization server directly, because your authorization server having all the different systems in your environment waiting for the authorization server. Sometimes it's just not feasible. So there are these steps. An admin revokes a token by talking to the authorization server. And now in the database, that token should be invalidated. We can do that by introducing an event broker, a central system that will relay the events of token revoked to all apps listening for that event. And now my colleague, whose token I just revoked, tries to get some data from an API in a completely disconnected system and immediately gets the access denied response, which is a terrible way to learn that you're fired. So with that, I would like to thank you all. So long, and thanks for all the fish.